Hello, people. Today, we have finally made it to Unit 10, the last unit, probability, sampling, and predictions. I am also finally not recording this first thing in the morning or last thing at night, so maybe we'll see a little bit more energy. Who knows? So, starting with these first couple problems, we're talking about probability, okay? I want us to remember that probability, the real definition is the number of desired outcomes out of the total number of outcomes. Okay, so let's think about what that means. What we like to say in class is that out of all of the things that could happen, right? The total number of things that could happen, what number of those things do we want to happen? And then I divide the number of things I want to happen by the total number of things that could happen, and that is what gives me the probability that this thing I want to happen will happen, okay? So, these first couple questions, it says find each probability for one rule of a regular number cube, right? And as a fraction in simplest form. Okay, so a number cube is also a dice, which looks like this, and it has 6 different sides on it, okay? If they asked you to list the sample space, that would mean list out all of my total outcomes, okay? Which is also going to be our denominator for each of these fractions. Well, the sample space, I could roll a 1, I could roll a 2, a 3, a 4, a 5, or a 6. So there are 6 possible outcomes, 6 total outcomes. Let's look at number 1. Number 1 says P, and then in parentheses 2. Okay, these mean 2 different things. P, first of all, just means probability. P means what is the probability, or the number of things I want, over the number of total things that could happen, of 2. Okay, so whatever I see inside of the parentheses is what I want to happen. So this is what I want. What you have to ask yourself is, how many of those things are there in my sample space? Okay, so this is a 2. I want to roll a 2. How many 2s are on my dice? Well, if I look at my sample space, there's only 1, 2. So how many things do I want? Just 1. Divide it by the number of total things that could happen. Okay, the total number of outcomes in my sample space is 1, 2, 3, 4, 5, 6. So I get 1 out of 6 is my probability. Okay, is this in simplest form? Well, I break out my calculator, which I have for once, and I would type in this fraction 1 ABC 6. I'm going to press the equal sign, but you said that nothing is happening. That's because this is in simplest form, all right? AKA, there's nothing that I can divide 1 and 6 by to make a simpler fraction. All right, let's look at number 2. We'll reset our sample space over here. Number 2 says, what is the probability that I roll a 3, 4, or a 5? So this is the stuff that I want. How many are there in my sample space? So a 3, 4, or 5, well, there's 3 of those numbers on my dice. So there are 3 different outcomes that I want out of, again, we have 1, 2, 3, 4, 5, 6 total outcomes. 6 is going to be my denominator for each one here, okay? So then, is it in simplest form? Some of us are already thinking in our heads, there's a number that I can divide 3 and 6 by. The easiest way, though, is to type in our calculator 3 ABC 6 equals 1 ABC 2. 1/2 is our simpler fraction. Okay, because 3 and 6 can both be divided by 3, which is what gives us that simpler fraction. All right, next one. Number 3 says, what is the probability of rolling an 8? Okay, so if I want an 8, how many 8s are in my sample space? Well, I don't see any 8s in my sample space. That's because there are no 8s on a normal dice, all right? So what's the number of things that I want to happen on my dice? There aren't any, okay? 0 divided by 6, or 0 divided by anything, is just going to simplify to 0, okay? So there's a 0% chance we roll an 8 on a dice that does not have an 8 on it. That makes sense. All right, number 4 says, what's the probability of rolling an even number? So I want an even number. Let's count up how many even numbers are on my dice. Well, 1 is an odd number, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even. So there are 3 numbers that I want to roll out of what's the total number of things that could happen? 6. 3 over 6, just like we saw with number 2, can be simplified to 1/2. There is 1/2 probability that we roll an even number. Next one, number 5 says, what is the probability that we roll a number less than 3? So, how many numbers are less than 3 in my sample space? Well, 1 is less than 3. 2 is less than 3. 3 is not less than 3. So that is just 2 out of the 6 total outcomes. All right. 2 ABC 6. Since they're both even numbers, I know this can be simplified. Equals 1/3. So 1/3 is my simpler fraction for number 5. And then the last one, 6, says probability of rolling a number 1 through 6. So going back to my sample space, 1 through 6 is all of my numbers. All 6 out of 6 are what I want, okay? If I typed in my calculator 6, ABC 6, that is going to simplify to 1, all right? Because I'm dividing something by itself. If I take 6 apples and divide them by 6 friends, everybody gets 1 apple. All right, let's move on to number 13. Number 13 says, color the spinner to match the given probabilities. Probability of yellow is 5/12. Probability of blue is 1/4. Probability of green and red are both 1/6. All right, so if I look at this spinner, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What would we even call these? I'm going to call them triangles. 12 triangles on the spinner. Okay, and let's start with yellow because I see a 12 right here. If the probability of yellow is 5/12, that means there are 5 of these triangles that I want, or 5 yellow triangles. So we'll call this one yellow. I'm just going to write a Y because I know you don't have colors in front of you. All right, the next one says the probability of blue. Notice that my denominator is not 12. This denominator says 4. So 1 out of every 4 triangles, which there's a couple ways we could do this. First, I could say, well, if it's 1 out of every 4, that would be this one, not blue, not blue, not blue. This one, not blue, not blue, not blue. This one, not blue, not blue, not blue. That would be 3. Let me show you another way we can think about this, though. That's a little bit more mathematical. I would want to turn this fraction, 1/4, into a fraction with a denominator of 12. How do I create equivalent fractions? Well, I multiply the denominator and the numerator by the same number. Kind of like here, number 2, how we divided 3 and 6 by the same number to create an equivalent fraction. We could also multiply the numerator and denominator by the same number to get an equivalent fraction. So at the bottom, I already know what number I want in my new denominator. Okay, so 4 times what equals 12? That is 4 times 3 equals 12. So if I multiply the bottom, the denominator, by 3, I also want to multiply the numerator by 3. 1 times 3 equals 3. So this tells me that 3 out of my 12 total options are going to be blue. So let's do blue, blue, and blue. I'm going to use that same strategy for green and red. So green, I want to create an equivalent fraction over 12. So I ask myself, well, what do I multiply 6 by to get 12? That is times 2. So I will multiply by the same 2 for my numerator. 1 times 2 equals 2. So 2 out of my 12 are green, G, G. And then red is the same fraction as green. So I know that this one is also going to be 2 out of 12. R, R for red. All right, let's move on. Number 14 says, Mark and Abby played a game which required flipping a coin. Mark won when the coin landed heads, and Abby won when the coin landed tails. Sounds like a very fun game. Below is the table showing their winnings. They want us to find the experimental probability that Mark wins and the experimental probability that Abby wins. So we didn't talk about experimental probability a lot in class. That's because it's something that you learned about in 7th grade. But we're still going to find these simple probabilities, and this is how, okay? What's the probability that Mark wins? What are the, so let me do this in blue because this is what I want. And before we were talking about what I want in blue. So if I want Mark to win, what's the number of times that he wins? Well, that's 10 times. Out of, what is the total number of outcomes? Okay. Well, there wasn't just 10 games played because Mark won 10 of the games, but Abby won 15. So I would want to add these together. 10 plus 15 would give me my total. 10 plus 15 is 25. So the experimental probability that Mark wins is 10 over 25. If we typed in our calculator 10 ABC 25, I would get the simpler fraction 2 over 5. Because I can divide both of these by 5. So there is a 2/5 chance that Mark wins, and we can use that same logic to find out the probability that Abby wins. So what is the number of time that Abby wins? 15. The total is the same, 15 over 25. And then I could type in my calculator, 15 ABC 25 will simplify to 3 out of 5. So 3 out of every 5 times that they play this game, Abby wins. C says, find the theoretical probability that Mark will get a win on the next flip of the coin. So theoretical means in theory, okay? In a perfect world, what's the chance that Mark wins on the next flip of a coin? Well, in a perfect world, there is a 50% chance that Mark wins because we're talking about a coin here, right? A coin has a heads and a coin has a tails. So there is a 1 out of 2 chance that we flip a heads because heads is 1 out of my 2 total outcomes. All right. Number 15, Paul hit 4 home runs out of 16 pitches at batting practice. So right off the bat, I'm seeing 4 out of 16. That just screams fraction to me when I hear the words out of. I know that 4 is the number of home runs I hit, so kind of like the things I want to happen out of 16 pitches altogether. So 4 home runs out of 16 pitches. It says, what is the experimental probability that he will hit a home run on his next pitch at batting practice? Okay, well, I have 4 over 16. Also, this can be simplified. ABC 1/4. Okay, so what would the probability that he hits a home run on his next pitch be? Well, it would just be this right here because every 4 pitches, I hit 1 home run, okay? So this next home run, we could even put it as a decimal, right? 1 divided by 4 would give me 0.25. If I multiply that by 100%, that would give me a 25% chance that I hit a home run. 25% chance of a home run. Okay? One more time to make it a little bit more clear. I took this fraction and divided by numerator 1 divided by 4. That's what gave me the decimal. And then if I multiply decimal by 100%, I get my chance of hitting a home run. All right, let's keep rocking and rolling. Number 1, you plant 20 marigold seeds and 12 of them grow into flowers that bloom. If you plant 10 more marigolds, predict how many would bloom. Okay, so this is going to be a way for us to talk about compound probability. So let me show you what I mean. It says I planted 20 seeds and 12 of them bloomed. And I want to know how many will bloom. So that's what I want. What's the number of things that I want? 12. Out of the number of total seeds that I planted was 20. Okay, so it says if I plant 10 more, how many of the 10 would bloom? Okay, I want to create an equal proportion where instead of planting 12 flowers, this time I want to plant 10. And I want to guess or solve for how many of those will bloom. So I put an X on the top of this fraction. Okay, this is a proportion I can solve with the baseball bat method. I see that this diagonal right here has 2 numbers, so that's where I'm going to multiply 12 times 10, and then we divide by the ball. So 12 times 10 divided by 20 is equal to 12 times 10 is 120 divided by 20 equals 6. Okay, so 6 is my prediction of how many would bloom. 6 would bloom out of 10. All right, number 2. Cameron threw 3 touchdown passes in one game out of 9 pass attempts. So what's the probability that he throws a touchdown pass when attempted? Okay, so if I want to know about touchdowns, that is the thing I want to happen, and that happened 3 times, so that's what goes on top. It says out of 9, which implies that 9 is my total. So it's going to be 3 over 9, okay? If you wanted to type ABC into your calculator, 3ABC9 would simplify to 1 over 3. B says Cameron has 12 touchdown pass attempts in a game. Predict how many touchdowns he completes. So we'll do the same thing that we did number 1, okay? Where now, if my total is 12, I want to guess how many touchdowns will happen. Or if I had this fraction, blank over 12, okay, how do I solve for how many touchdowns, how many things that I want to happen will happen? Well, I'll set this equal to either one of these fractions. I'm going to use 1 over 3 because it's going to be smaller numbers. All right, and we are just going to use the baseball method again. So I multiply my bat, 12 times 1, and I divide by my ball. So 12 times 1 equals 12, divided by 3 equals 4. So I would predict that he would make 4 touchdowns if he had 12 pass attempts. All right. Number 3, we are going to say, thank you, Miss Majorana, and we are going to cross out A. And then I want you to cross out the first part of this sentence, okay? Because that would be a whole group activity that we don't have time for today. So number 3 says, Lana surveyed 30 students. She asked for their favorite type of movie. Their responses are below. It says, predict how many out of 60 students would choose drama as their favorite type of movie. Okay, so I know that I want drama. Okay, let's find the probability of drama from this table. Probability of drama. So if I want drama, there are 5 things that I want from this table. For total, I would have to add these all together. So 6 plus 5 plus 15 plus 4 is going to give me 6 plus 5 is 11, plus 15 is 26, plus 4 is 30. So 5 out of 30 kids picked drama as their favorite movie. So they said, predict how many students out of 60 would choose drama. So I'll take this fraction, 5 over 30, and I will set it equal to a fraction where the total is 60, so I can solve how many of those 60 students like drama. Well, there's 2 ways we could solve that. I'm going to use the baseball bat method. If you could use kind of thinking about what I would multiply 30 by to get 60, and then doing the same for the numerator, you are awesome. I'm going to use baseball bat method though. Baseball bat method would tell me to multiply 5 times 60 and then divide by my ball 30. Okay, 5 times 60 is 300, divided by 30 equals 10. So I would predict that 10 students like drama movies out of 60. My last one, number 4. Number 4 says, rangers in Montana wanted to estimate the number of elk in a certain area. They tagged 20 elk one Saturday and sent them back to mix with the other elk in the area. The rangers went back once a month for the next 3 months and recorded the following. So it says each month I talk about tagged elk and I talk about the total elk in the sample, okay? So the number of elk that we want to see out of the total number of elk that we saw. So it says estimate the size of the elk population for each month. Estimate the size of the elk population for each month. God bless me. All right, let's think about this for a second. So it says I tagged 20 elk and sent them to mix with the other elk in the area. So I'm thinking this is what they want us to do here, is to set up proportions. So for month 1, let's start there. Month 1, there are 4 tagged elk that I see out of the 7 elk that I see, okay? We know that altogether there are 20 elks that they tagged, okay? So if tagged elk is what we're writing in blue, I would put 20 on the top of my fraction, okay? Out of this X would represent the size of the elk population that month, okay? Because that would be the total number of elk I saw. So we would solve this proportion by multiplying our diagonal with 2 numbers, so 7 times 20, and then dividing by the ball, dividing by 4. So 7 times 20 is 140, divided by 4 is going to be 35. All right, I'm going to do the same thing for month 2 and month 3. So month 2, I have 6 out of the 10 elk are tagged, so 20 out of how many total? I would do 10 times 20, divide by 6, so 10 times 20 is 200, divided by 6. That's not going to be a nice number. Let me see, I finally have my calculator next to me. Yeah, not a nice number, 33-ish, 33.3 repeating. And the last one, month 3, I have 12 out of 18 elk that are tagged. So if there's 20 elk tagged altogether, how many in my total population? For this one, we do 18 times 20. Divide by 12. 18 times 20 is 360. Divided by 12 is 30. So we see our elk population go from 35. It's our total population, so let me highlight in red. From 35 to 33.3 repeating to 30. All right, you are finished with your review. At this time, we should be going back through and making sure that we have turned in all of the unit reviews 1 through 9. We should be doing some IXL review before our test on Thursday, and we should be chilling, all right? Let me know if you guys have any questions on Canvas or in class, and I hope you have a great day. Goodbye.